So the point of this meetup is, Web3. I guess it's one of the first things that we've done since getting everything together with the foundation. And it's kind of commemorating the end of this digital exchange workshop that we hosted, which I hear was a pretty decent success. So kudos to Maria Paula, Ashley, Jennifer, Peter, and the rest of the team for sorting that out. The point of the Web3 Foundation and the reason that we did the Decentralized Exchange workshop and the reason that we're working on the Polkadot protocol and the reason that we are planning on supporting various other projects in this ecosystem is primarily for the decentralization of the web and for the proponing the tools that we think are going to be able to create the platform on which we can build the services for humanity in the coming 20 to 50 years. So it's it's not a small job, and we don't want to do all of it, but we do want to help out where we can. And these workshops form the first step towards that. So a couple more workshops that we want to do in the near future include an on-chain governance workshop where we want to talk about how we can bring the idea of stakeholders within a relatively closed crypto ecosystem together to make decisions to move that ecosystem forward in an effective manner, fair, whatever you are, transparent. It's actually quite difficult to name precisely the attributes that we want of this, but we do know that something like this is needed. And to what's the other workshop we want to do, Peter? Blockchain scalability, right? Yeah. We got lots of ideas in that direction, but yeah, I think it's worthwhile actually getting people around a table to hash out what the most promising ones are and whether there's coordination, cooperation, or self-enlightened competition that can help drive the space forward. I don't want to speak too long, so I guess that's probably most of my points made, and I'd like to pass on the baton to Peter, who's going to talk a little bit more about what the recent outcomes of the Web3's activities are. Cheers.
All right. So as Gavin mentioned, the Web3 Foundation is set up to generally support the Web3 ecosystem. We've just recently started, so we are figuring out what are the kind of most effective ways in which we can push the space forward and getting the team together. But generally, the different areas that we want to focus on is research, fundamental research into topics that are needed to build those technologies. Then supporting the development of protocols and a kind of consistent stack of technologies that will enable then developers to develop decentralized applications. And then also support the ecosystem, so connecting different projects together, organizing workshops, communicating recent outcomes online, maybe making a knowledge repository around this space. But in general, trying to be very targeted in the way we do things. So let's say with the meetup today, we try to cover one particular topic pretty in depth. We also encourage the projects to talk more about this technology that they are working on more generally, rather than about their particular project only. So that the event is not only helpful for their interaction. That was kind of what was useful yesterday, where there was a more concentrated group of people, but rather there is something that the community can also take out of it. So yeah, I want to thank everyone that helped out as well, besides the Web3 Foundation, the factory for hosting us, and Gnosis, Blue Yard, and Melonport for helping out with drinks and food. In general, we are very much open to community members getting in touch with us. We are, if you go to our website, web3.foundation, you can find our Riot, where you can have conversations about Web3. And if you have any initiatives or things that you think would be impactful for the space, please get in touch with us. And now I want to hand it off to the projects it's a subset of the teams that participated in yesterday's workshop. Anything else? To Radar Relay. And you can get in touch, hello@web3.foundation.
Thanks so much. Hey guys. That's very nice, but I haven't started. So, Alan Curtis with the Radar Relay team. Really excited to be in Berlin. We flew in just a few days ago from Colorado. And I've got a secret for you guys. Please don't tell the rest of our team. I think we're going to miss our flight tomorrow morning so we can hang out in Berlin some more. This has been an absolute blast. Thanks to the Web3 Foundation and all the folks that were mentioned earlier for herding a bunch of cats and getting us decentralized exchanges together yesterday, which is a hard task in and of itself to get us all in the same room, but even a harder task to concentrate us all on these hard issues. So stay tuned for some of the deliverables and action items coming from the event yesterday. I've been asked to spend about 15 minutes or so chatting about exchange categories, the movement from centralized to decentralized, and then introduce Radar Relay. But before I do that, I'm so curious, who here, maybe show of hands, has used Radar Relay? Awesome, okay. So for those of you watching at home, the whole room stood up, both hands, everybody went crazy. But in all seriousness, for those of you who have used Radar, thank you. It's been a blast launching our little project and it turning into a company over the last few months. I'd also like to point out there's a few radars here in the crowd. Maybe you guys could just raise your hand in the back corner there. The reason I have them raise their hand, if you've used Radar, or if you're going to use Radar later and you've had bugs or things didn't work, please talk to Caleb and Brad in the back. They can't wait to hear about it. If you've had a great experience, please come find me after. I can't wait to hear about it. So, anyways, what I'm going to do here. Awesome. So we're going to talk about three big areas, this movement of exchange technology or transitions, introduce Radar, and then just touch on the 0x protocol. So for most of us in this room who have been crypto trading or been in this space, we've all used centralized exchanges. There's 180 plus of these. They're all over the world. They're names like Bitfinex and Bittrex and Binance, and I'm sure this room could collectively list all of them. And they're doing billions of dollars in daily volume. And it makes a lot of sense. It makes a lot of sense when you're bringing a new technology to market to use a centralized technology, a centralized exchange. You're able to adjudicate transactions. There's a hierarchy. You know who's in charge. But of course, as you've seen in the news, and maybe some of you have experienced, when you give custody to an exchange, when the funds leave your wallet, go to the exchange, yeah, you get faster trading. There's quite a bit of friction. There's quite a bit of security breach and quite a bit of danger. So I'm not going to list off all the exchange hacks, but if you add them up, it totals to billions of dollars. And that's pretty scary, and that's a pretty serious market need. And when there's a market need, the market responds. And we've seen decentralized exchange. So there's many different types of decentralized exchanges, and it's hard to really put a definition to a decentralized exchange. The easiest one that we could come up with is when users give custody, instead of to an exchange, to some sort of escrow service. So think smart contracts in the case of Ethereum. What's interesting to note, this transition, sort of the hop or the catalyst was really the smart contract. And that allowed users to skip the KYC, skip the account creation, skip the friction, skip the wire limits, skip the deposit fees, transaction fees, withdrawal fees, time between exchanges. And at the Radar team, we watched this transition play out. And we're really excited because this is what we believe in, is this wallet-to-wallet trading. We believe in this is control over funds. But we still felt like there was opportunity. There was something next. There was another transition. There was an evolution of exchange technology. We were looking for that spark. Right? The smart contract was the spark that unlocked decentralized exchanges. So what's that spark? That's the 0x protocol. We're going to talk a little bit about that in a minute. The third category is the relayer. And if you haven't heard of relayers, because it's pretty new. We are the first radar relay of many. I think there's a dozen. I think maybe one was announced this morning, so maybe 13 at this point. And you can think of a relayer as the next logical extension of a decentralized exchange, where instead of depositing funds into an exchange or into an escrow service, you hold onto those in your wallet. And I'll dive into how that works, because I know a lot of you engineers in the audience are asking, well, what the heck, what's the architecture? So just bear with me for a minute. I'll tell you a little bit about radar first. So what is radar relay? So if you went home and you Googled this, you checked it out, you'd find an interface just like this. Looks a hell of a lot like a traditional exchange. And that's very purposeful. Right? We wanted to create something that fit with the mental models of the participants of centralized and decentralized exchanges. We wanted to create a front-end user experience where people felt at home, they understand how it works, they know what the buttons do, they know what the graphs do. But if you opened up the hood, you looked under the hood, you kicked the tires, and you looked at the architecture, you see it's very different. So the user experience is pretty simple. Users who have funds in their wallet, tokens in their wallet, cryptographically sign an order, radar, acting like a bulletin board or a display service, displays that order, and then when pairs settle, it's on-chain, on the Ethereum blockchain, through the 0x protocol. That's it. We've, just a little bit on the company. So this is pretty new. I mentioned, right, if you haven't heard of Relayers, it's because this company was formed in August. We got on testnet in September. We launched in October. We raised a seed round in November. We've been hiring in December. And really, January has been the first month, hence the meeting, presentation, us really starting marketing. We're trying to share more with this community about this new third category and bring relayers into awareness. But we're not the only one, as I mentioned, right? There's many different relayers. So feel free to check out the site, and please give us feedback, right? We're still early stage, things are still being built, and there's no way we would have been able to hit these major milestones without the community constantly poking us, hey, I want this functionality, or you've got this bug, or I'd like to see this type of order structure. So please, community, continue to keep up the feedback for us. So 0x protocol, this is that catalyst that's unlocked this latest category, and this is what I'm the most excited about. And although I kind of just ask you to check out Radar and tell us what to break, my big ask for the audience here, if you haven't heard about the 0x protocol, is please check it out. If you're a developer, they've got great tools. If you're an entrepreneur and you want to build something, spinning up a relayer it's a great project to roll your sleeves up and figure out what's going on with the 0x protocol. So three pieces that I'm going to touch on, because to deliver a presentation on 0x would take a bit longer. I think there's somebody here from the 0x team tonight, so feel free. I can point you towards them later if you want to go deeper. So 3 things here. The first critical piece, 0x allows users to cryptographically sign orders directly from their wallet. Piece number 1, right? Without that, relayers don't exist. Number 2, they've built a suite of smart contracts. They've wrapped them up in JavaScript, so they're real easy to play with and build, like building blocks, and allows orders to settle on the Ethereum blockchain. And then third, and what's most exciting to me, and most important to me, is the governance function. So 0x also is a token. And I think some of the questions that will come up probably after this will be about the token mechanics. Happy to chat about that. But what does it mean to have governance? Well, as we all know and we love about decentralization, there are some challenges. How do we make decisions as a group? How do 0x participants, like relayers, decide to improve protocols? Or how do we engage as a community? And the way that 0x is thinking about governance is pretty incredible. And it's one of the reasons why we went out of our way to use a token. So that was intentionally really fast, right? I wanted to share with you guys a little bit about what is Radar, how we think about this progression, right, from centralized exchange to decentralized to relayer. And I want to spend a lot of time answering questions because this stuff is new, right? And these theses that we have, we're still working through them. And so I'd love to use the remaining time, and I know we've got a lot of it, to jump through some hoops for you guys and answer some questions about Radar or how 0x works.
Hi, everyone. My name is Balaj, and I'm the founder of probably the only decentralized exchange in Berlin. We participated in yesterday's workshop with the other decentralized exchanges, and I will lead the Q&A for all of our decentralized exchange friends from overseas and Asia. So my first question would be, could you guide us through the fee process and how would it work from the user's perspective? Where do the fees go? How does the money flow in the system? And if there are any security risks whatsoever involved?
Sure. It's a softball question to start. Yeah, so fees. So right now on Radar today, if you visit our site and you want to trade, there are 0 fees. This is not a profit-taking endeavor for us right now. This is about introducing a new product to the market. So we've wanted to decrease the amount of friction that users have. And so right now, 0 fees, and you can count on 0 fees for a little bit. So, but the real question is, if we did turn fees on, what does that mean for the end user? What are the economics behind that? Right now, when you submit an order, when you look at your order parameters and you're submitting an order from your wallet, the fees are baked into that order schema, that order parameter. And so when those are submitted, this is where it gets complex, and I know why you asked this question. When it gets submitted, and it's on the book for an arbitrarily long period of time, right? Could close in 2 blocks, or it could sit on there forever. You're subject to the price volatility inherent in the fee token that is 0x. So to say that even simpler, Balaj puts an order on the book, sits there maybe for a few weeks. I take that order, but now the 0x fees that he's paid, maybe 0x has gone way up in price. And so he's exposed to some volatility risk. Or if it goes the other direction, the relayer is then exposed to the volatility risk. So the reason he asked that question, I think, was to bring up one of the great examples of what it means to be in a new category, which is there's some problems and there's some issues. And there are reasons why 0x has governance. There are reasons why 0x is in V1, and they're aggressively moving on to V2. And I think that's one of the reasons right now we haven't turned fees on, is because that's a great example of friction point.
Cool. Yeah, I think we're going to start taking questions from the audience, so
Take your hand
dig
up.
deep.
Yeah.
I'm already counting the microphone back.
Yeah.
Apologize.
Hi, I was at a meetup last week, and Zurich and the founder of Lique was there speaking about the fact that they have moved from a decentralized to a centralized model because they were saying that the current ecosystem of the time it takes for transactions to happen is too high, and it's just not feasible to actually run a decentralized network in their model. And I just wonder if you guys can speak to that in light of the 0x protocol and how that's changing, some of these issues.
Sure. Yeah, so the question was, doesn't it take a long time to do transactions on decentralized exchanges? Yeah, it does, absolutely. And I think if I had a chart of comparing centralized, decentralized, and relayers, and I had a chart with a bunch of boxes and X's, I would certainly own up to that fact. But that's one of the trade-offs and one of the realities of owning custody and maintaining custody is that you opt into that experience where you've got Ethereum block times and you've got to use gas. And I actually like that as an aspect of relayers for people who truly value that security and privacy. And I'd like to take those, I'll call them speed bumps in the exchange experience, own them as part of the category, and use them as more of a differentiator as opposed to something to be really scared about. So we lean into some of those challenges. Yes, we are looking for solutions as well. Interestingly enough, the folks here in Berlin seem to have all the right answers for how to do that, I think, which is why we're going to be back pretty soon. Yeah.
Hi. What advantages do the relayers have over the decentralized exchanges? Is it really like like a real step change in advantages, or is it just like minimum benefit?
Sure. So the question is are relayers just incremental innovation from a decentralized exchange? And it kind of depends which decentralized exchanges we're talking about. So if you use the category of Ether Delta, for example, on Ether Delta, you're depositing into a smart contract where it's kind of quasi, right? You lose custodianship over your funds to that smart contract. So that's piece one, right, from a relayer for folks who always want to maintain ownership of those funds. Now, depending on your user as well, so if it's a retail user who's just looking for XYZ token, for them right now, incremental. For an automated trader, it's a huge step forward to be able to own custody of your funds. And then here's the really exciting piece that has forced us to create this entire new category, which is around how we engage with dApps and other relayers. So for us, it's really exciting to see relayer number 2, number 3, number 4 launch and be able to share share liquidity with us and have one order book. So that's the piece about relayers that I didn't really go into here because I assumed it was going to come up during Q&A. But that's really the outstanding piece that's not incremental, is how we play together in the sandbox really well.
Hi. Is it on? So as far as I know, like in the 0x protocol, it's expected that the order book is off-chain. So I wanted to know if doesn't that expose you, a company like yours, to regulation?
So the question is about regulation. If I give you a long answer, that means I'm going to send you an invoice for my billable hours afterwards. Hope you know that. But the short answer, so as a layer not owning custody of funds, we do not meet the criteria of being an exchange. So you look at some of the legal regulatory actions, right? SEC, FinCEN, CFTC in the US and some of the work abroad, they're really focused on money transmitters and folks who are assuming custody of user funds. But if you've got an open order book where you and your peer are going wallet to wallet, we're just a bulletin board, we're not exposed to those regulations. That being said, when we first conceived of this idea, right, this was all the way back a long time ago in crypto land, I think in July of last year, we had the idea and then we started with regulatory. So we didn't build a line of code, we didn't start anything until we spent more money than I want to admit talking to attorneys, trying to understand these issues, talking to regulators. So sort of the regulatory question had to be answered first, and we're really excited and very satisfied with our place in the regulatory landscape. I'll invoice you later.
Yeah, hi. Can you hear me? Yeah, okay. So first of all, I'm very grateful for projects like yours, and I think anybody who has witnessed, transferring their funds to one of those exchanges and, sometimes having to wait for hours and sometimes not even being able to withdraw it is also probably very grateful for your project. But my question is, what about scalability? Because, we've even seen it with centralized exchanges that they can't handle the amount of orders that you have when there's a lot of orders, yeah. So how do you handle that?
So the question's about scalability. Next question. So scalability is what keeps me up at night, frankly. So when we were starting Radar, what kept me up at night was, will we find the liquidity inherent to grow this thing, right? So automated traders, and I feel really confident that leap of faith has been addressed. And the second question is scalability. Are we going to break this Ethereum thing? Is this going to work? And that was actually one of the reasons we came out to Berlin. Was a lot of that work around scalability is being done here. Well, it's distributed around the globe, but a lot of it is being done here. And in particular, we just met with a project a few hours before this that we feel like is, well, I'm sure I can share, the Cosmos project in particular is something that we're looking at as a really near-term opportunity to improve some of the throughput, improve some of the scaling. So for us, we have an internal strategy team at Radar. So we've got a few different business units. One of them is strategy. Caleb, who's our chief strategy officer, is here. If you want to go poke him and ask him some really detailed questions. about scalability. That's all he focuses on, is assessing new projects and figuring out how we're going to solve that problem. But frankly, what a great problem to have for a new project is if we're coming up against the threshold of scalability.
Okay, we have to pass.
Great.
Mike.
Cool.
And
Thanks.
welcome Michael from AirSwap.
Thanks so much, guys.
Hopefully this works. Okay, so I don't think the the graphics were set up, but we'll be okay, I think. So yeah, it's really amazing to be in Berlin. It's my first time. It reminds me of Brooklyn, which is where I live. It's a really great energy, really great creative energy, and I'm really thankful to be out here. I think it's like one of the few cities in the world where I just landed here and I walked around and I was like, okay, I could actually live here. So pretty cool. My name is Michael Oved. I go by my last name mostly. My last name is Oved. That's what my friends call me, so please call me Oved. My previous life was in algorithmic trading, so I was part of the revolution where computers replaced humans on Wall Street completely. I was with a small company called Web3 Financial, and we grew it to a pretty big entity, global entity. I was part of the Asia operation. I lived in Sydney and then Singapore. So got to grow that out, and after 7 years being with that company, we IPO'd in 2015 for $2.5 billion. So it was a really incredible journey to be a part of, and really taught me a lot about exchanges, how to build scalable platforms, and also teaches you a lot of the intricacies of every exchange. And all the intricacies are something that traders ultimately can exploit or use. So when you design an exchange, you need to be thinking about all the details. So I'm just quickly going to jump into the design of AirSwap. So it's 3 points. It's basically you find tokens through the indexer. The indexer is essentially your centralized place where you can find everyone else that's doing something on the network. So we're building a peer-to-peer trading platform, strictly peer-to-peer. And in a peer-to-peer trading network, you basically don't have information about where anyone else is, and the indexer is essentially your BitTorrent or your tracker, where you can find where everyone else exists. Once you find them, you just connect to people directly peer-to-peer. Then you set prices through your Oracle, and on a decentralized dark trading network, you don't have price discovery, right? So you have only the prices that you're being given are the ones that you can trade at. And so the Oracle is essentially our way of providing some sort of fairness to the system, where the Oracle is telling people, hey, this is kind of a price that you can use. You don't have to use this, but you can use this. So it's kind of like if you go on eBay, or you go on, or you're buying a car online. Usually there's recommendations for prices, and this is an optional mechanism that you can use in our ecosystem. So in this example, the maker is querying the Oracle for price suggestions. And the third part of the ecosystem is making trades on the Ethereum blockchain. So you find tokens, you set prices, and make trades. This is a very simple process for users. We intend to make a retail trading platform that's very easy for people to use. So our design it's private. There's no public order book. It is scalable because you don't need to update the state of the order book. And it's fair because there's no front running in our design. This is a unique feature, I think, of our design, is that basically when people are placing orders and trying to execute orders, you don't have your orders subject to front running by either the miner or the exchange itself. So we like our design for a number of reasons. One is that there's one global trading network. You don't have to share liquidity across, you don't have to compete for liquidity across multiple exchanges. We like our design because the orders are passed privately between peers. The other reason why we think this design is going to work is because market makers essentially have lower risk. When you're placing an order on a public order book, you have the risk of people picking you off. And in this case, you're just placing orders privately to someone who has already indicated interest. And so market makers are most likely going to prefer this design over other designs. In this design as well, there's no cost to updating prices. So there's not, I mean, in a public order book, basically you have market makers are placing and canceling orders continuously, constantly. And in this design, because you're placing orders to someone who's already indicated that they want to trade, you most likely won't have to cancel that order. Like we talked about before, there was no front running, and this last point is something that we'll jump into a little bit, but basically our peer-to-peer trading networks are very popular in certain asset types, and one of our theories is that a lot of the assets that trade, a lot of these ERC20 tokens are going to be more suitable for peer-to-peer than they are for order books. So this is our roadmap that we're building out over the next probably 3 to 6 months, I would say. First is the token trader. And well, the first was the token launcher. So we launched AirSwap through our own platform. We launched the AirSwap token through our own platform on October 10th, 2017. The second is our token trader, where we're introducing new components to our design. The third is when we introduce the indexer. So this is when we become a marketplace, and this will happen pretty soon. And the fourth we're calling the partner network, which we're going to release more details about pretty soon. So you can try the beta at trade.airswap.io, and we're currently on the mainnet. This is really exciting for us. We're probably going to open up our mainnet to the public, so anyone can trade AirSwap tokens through AirSwap pretty soon. So they told us to just like pick a topic that we want to talk about that's not totally related to the project. And so one of the things I want to talk about is there are all these centralized exchanges, and they're all pretty liquid and competitive, right? So this next year is going to be the year where we have to take, as a community, we have to try to take liquidity away from centralized exchanges and move it to decentralized exchanges. And this is not going to be an easy task. It's going to be a big market share play. There's going to be a lot of competition. I mean, like, Alan said before, there's 180 centralized exchanges, and this is going to be something that we all need to focus on. The decentralized exchanges really need to focus on. So here are the options, and this is kind of me breaking out the different designs. So, I mean, this is the way I see it. So decentralized on-chain exchange will be something like OmiseGO. Decentralized off-chain exchange. Off-chain order book exchange will be something like 0x, Relayer. Decentralized on-chain orders are going to be Kyber, and decentralized off-chain is AirSwap. So my question here is, can we compete with Binance? Can we compete with Bittrex? These exchanges are highly liquid, and they're liquid for a reason. My thesis is that they're liquid because you have a lot of automated market makers. You have a lot of algorithms that are running on these exchanges that are able to place and update prices pretty constantly. I mean, this is the case in classic Wall Street, and it's become the case in centralized exchanges as well. So what is Binance really good at? So Binance has low latency. It's very highly scalable exchange. It has low fees. Placing and canceling orders is continuous and can happen without being charged anything, and it has high liquidity. So this is kind of, if we want to compete with Binance directly, we're going to have to solve these three things. So, and then we just talk about liquidity types. So I kind of break these into two different categories. There's highly liquid assets, which are assets that trade many times per day, And there are smaller orders, and it's kind of these layering of orders onto an order book where people can come and remove liquidity from those exchanges. And the order cancel order loops are very common. This is essentially how automated market makers work. And this ends up resulting in a tight bid-ask spread. So there's also less liquid assets, and I think that, you know, my thesis is that for the less liquid assets, it's going to be easier to compete with these centralized exchanges directly. So less liquid assets generally have fewer trades per day. There are larger orders that get executed, and generally have a wider bid-ask spread. So I think there's a lot of entrepreneurs and technologists in this room, and I think that if we try to answer the question of how do we match the liquidity type of the asset itself to the exchange type, if we start with the liquidity type of the asset and then try to build an exchange around that liquidity type, we could effectively bring this trading from centralized exchanges to decentralized exchanges. And you know, one of the really interesting things that we saw from our DEX workshop yesterday was that there is no low latency cross-chain decentralized exchange being produced. And I think that, you know, as seed channels become a more accepted solution, this might become possible, but I think that this is kind of the golden egg. If we build something like this as a community, we'll be able to take liquidity from Binance, et cetera. And now I'll take any questions.
Yeah, so you mentioned that you don't have active price discovery or an order book. Where do you see AirSwap in the future? Do you focus on bigger market makers and high-frequency traders, or what's in the future for AirSwap?
Yeah, so this is kind of, you know, relating to the liquidity type of the asset itself. So there's no price discovery, there's no public price discovery, but there is private price discovery. So basically, when you receive orders, those orders are things that you can execute yourself. And so there's no public order book where everyone can see everything, but you're still receiving price discovery that's local to you. So it's something more like an eBay model where you put out a request and people send you all your prices. So as long as you have multiple people providing quotes, I think that you'll get a competitive experience. And then I think the second question is, what kind of liquidity types do we focus on? So I think the first is medium-sized liquidity. There's a ton of shops, a ton of companies that are holding kind of these bigger balances in tokens, and trying to get out of that balance on a centralized exchange will cause all the algorithms to kind of pile on top of each other and move the price. And so it makes sense to get out of that position privately, peer-to-peer. So I think that's kind of the first thing we focus on. And then there are HFT solutions that we can pursue as well, which is similar to how the broker networks in FX work.
Cool, thanks.
The usual question. What about regulations in your case?
Yeah, so I think regulation is one of the most interesting and hardest things to answer at the moment. It's something we're working really, really closely with a lot of top people on. But and actually, one of the really cool things about the DEX workshop is that we came up with ways where we can share resources in our regulatory approach. Similar to what Alan said, because we're not in custody of assets, it's a little bit of an easier situation to manage. The literal written word of the law actually, you know, decentralized exchanges I don't think are totally covered by the literal written word of the law right now. But if these things become very popular, I'm sure the regulators are going to start to look at it. I do think that there is the opportunity to be responsible and you know, engage with regulators. I mean, we're incorporated in Hong Kong. We're engaging with the SFC directly, and I think it's. I don't have a good answer about regulation. I think it's one of the most interesting problems with this space right now, and I think it'll evolve a lot.
Because there is, I'm coming from another meetup where was highlighted the issue also of users. For example, users from the US trade on your platform, and somehow they buy uninformed in an uninformed way on this platform, etc. You might incur in legal risks. You know, the Americans, they love to sue. So just a topic that was touched during that meetup, of course, with no solution, but except for a lawyer pushing his interest, her interest in that case, to always consult a lawyer and just in case do things that are US compliant. But
yeah, and you know, I don't think it's going to be hard to be compliant with the current way the regulations are written. I don't think we're sidestepping the regulations necessarily. You know, if we were in custody of people's funds, we would have to register. It'd be pretty clear what we would have to do. But the fact that essentially what's happening in these exchanges is you have one peer selling directly to another peer, right? So it's the same thing as you going online and selling something on eBay to someone else or on Craigslist. I don't know what the comparison is here, but you're not regulated in that case. You're allowed to sell what you own. So,
okay, thank you.
Question, yeah.
Donde?
Hey. This may be a stupid question, but
sure it isn't.
The plan for AirSwap, will it support token trading based on any platforms or any networks, or is it like specifically built for, you know, like Ethereum tokens, ERC tokens, or will it be across all currencies and platforms? What's the vision and the plan?
Yeah, so ERC20 tokens are standardized, and they allow you to call the transfer function. Basically, every token you probably interact with is an ERC20 token. So that's kind of the easiest place to start, and that's where we're going to start. We do have ambitions to touch all chains. I mean, we're fans of every chain. I think that a strict peer-to-peer design is a lot easier to do cross-chain transactions. It's also easier to have scalability solutions like Lightning Network. So, I mean, we start with the ERC20 and then we build the tech to be able to support everything, definitely.
Hi. How do you implement privacy on your platform? You were saying that it's completely private.
Yeah, so the orders are passed peer-to-peer and they're most likely encrypted. So, you know, it's basically wallet-to-wallet, two wallets communicating with each other. And once the execution happens, it's public. But as the order is being executed, as the order is being communicated, it's private. So in the case of an order book, basically you're publishing the order to the order book. Everyone in the world can see it. In this case, you're just passing an order to someone directly peer-to-peer.
I didn't understand exactly why you took this decision to not have an order book.
So this is a strict peer-to-peer design, and we think it's better suited for blockchain. If you try to do order books and all sorts of, if you try to decentralize, basically an order book is, you know, in our thesis, an order book is something that's designed for centralization. Right? It's a central location where everyone can come, they can submit their orders, both physically, and you want it to be physically and logically centralized, right? In order for it to be a really efficient system. Once you try to decentralize it, right? Blockchain it runs on multiple computers around the world. So once you try to decentralize something like that, you start to introduce all these issues, like minor front running and a bunch of different race conditions that you can introduce. And so we were kind of thinking about it. What is blockchain? How would blockchain actually be able to support an exchange? And this is kind of the design we came up with.
All right, thank you so much. I've been calling you Michael this whole time, but now
Yeah, that's
I'm
fine.
realizing.
That works.
I think we have Chris. Chris coming in from Gnosis. A little bit of a local flair.
Where's the click? So hi everyone, my name is Chris. I'm the product manager of the Dutch exchange at Gnosis. And I'm really happy to introduce you to our mechanism and our design. So what is the Gnosis Dutch exchange? Can somebody help me, please? Oh, there we go. So it's the Gnosis Dutch exchange is a decentralized exchange for ERC20 tokens using the Dutch auction mechanism to determine a fair value for tokens. So what does that mean? Let me take that sentence apart a little bit. So decentralized exchange, we're built on the Ethereum blockchain, and obviously there's no intermediary necessary. For ERC20 tokens, so we're compatible with all ERC20 tokens, so you can't use Ether, you need to use wrapped Ether, there are no fiat currencies or any other blockchain cryptocurrencies. So we're using the Dutch auction mechanism. I'm not sure if you're all aware what a Dutch auction is. So basically, traditionally, it's where a price falls rather than the other way around, and the first buyer who wants to pay that price will get the good. So if you have multiple fungible goods, the price keeps dropping until all the goods are sold. So and they are sold for the last price to all the bidders. So we're using that mechanism to determine a fair value for tokens, fair being that the people who are bidding actually have an incentive to only bid at their willingness to pay for it, because they will receive it either at that price or at a lower price, right? So the way we do this, we do it in a two-step process. So let me run you through that. So first, the sellers are active. So when we talk about an auction, we really mean for any kind of token pairing. So let's say the whole process is the same for A, B, C, C, D, whatnot. So let's go through A, B for the time being. So all the people who want to sell A will place their order in a pot in the sell volume. Then after some time, the auction will start. During the auction, all the bidders are active and place their bid at their willingness to pay. Then the auction, after all the tokens have been sold, attributed to the buyers, the auction will clear, and the sellers receive their B tokens, and the buyers who bought with B will receive their A tokens, right? And then after that, the next auction starts. We do this for, so if you have A, B, you also have the auction BA. Those run in parallel. So when does a particular auction pairing start? So each auction pairing starts at the same time, A, B, and BA, that being, it starts the earliest 10 minutes after the last one of those two closes. It can only start if the accumulated pot is as much equivalent to $1,000, and it will start at twice the last closing price. So that's really important to A, if you have price fluctuations, and B, the price function is designed to drop quite quickly and then slower, and we'll go through that in a minute. So when does an auction end? And I'll show you on the graph in just a second on the next slide. So either the last bid closes an auction, or the time function reaches a point to clear the auction. If there are no bids, which theoretically is possible, the auction will run to zero after 24 hours, but economically that's not expected to happen. So how long will an auction take? Well, we don't know. It depends on the price, but the price function is designed so to reach the prior closing price, which is a pretty good indication at any point after 6 hours. So I told you there are two steps. First, where the sellers are active and place their sell order into the pot, and then the next step when the auction actually runs and the buyers are active. So what does that second step look like? So here you can see, so this is token A Ether. Let's take AB. The price starts quite high, and then, so the sell volume is fixed, right? So no sellers can attribute any of the sell tokens during a running auction. This is done ahead of the time. If they want to sell AB while this auction is running, they will just place it into the auction pot for the next running auction. So you have a fixed auction pot, 500 A tokens, and then bidders will, at the time that the price is right for them, will start submitting their bids. So the pot will fill. So let's say at this point, nobody wanted to continue to bid, then you would see that the volume here would remain the same and it would clear the auction at this point, right? So here we see a bid at this point in time after 6.5 hours has closed the auction. Cool. So what kind of tokens do you need in the Dutch exchange? So from Gnosis, we just want to point out there are no particular tokens that you need to be part of this auction mechanism and of the Dutch exchange. So you don't need our GNO tokens. You don't need OWL. For those who don't know what OWLs are the tokens created by locking down your GNO. So it's kind of a coupon generated by our own tokens. You don't need to use them, but you may use them to reduce your fees, to pay for up to half of your fees. So tulips, I know a great word, tulips are intrinsic to the Dutch exchange. They're actually created by you trading on the Dutch exchange. So every ether worth of a trade of a whitelisted token will gain you 1 tulip. Why are tulip cool? They're used to reduce your fees, and we'll get to that in a minute. So they are inflationary. There's no way to reduce them. And they're locked by default, so you can make use of that fee reduction mechanism. But if you want to sell them, you may unlock them, and after 24 hours, they're tradable. So what are the fees on the Dutch exchange? So we've set the same fees for buyer and for sellers. It's 0.5%. However, depending on how much tulips you hold as opposed to the whole tulip market, you may reduce your fees. So if you hold 10% of all tulips, your fees are 0. If you hold 1% of tulips, you still have to pay only 0.1. And that's a continuous function that you can see up here. So you may pay up to half an OWL. Why would you want to do that? Because on the exchange, 1 OWL is the equivalent of $1 worth in fees. And you you might just hold GNO and have some OWLs, but you may buy them for less in the market, right? Okay, so who are the beneficiary of the fees? So the fees that are paid in OWL, they're burned, so they're consumed, they're sent to a smart contract without a private key, and fees paid in the token that you're participating with, which you have to do if you don't pay in OWL, you pay in the token you're participating with. If you pay it in that token, they're actually attributed to the next running auction. So we keep the fees in the ecosystem. So tulips don't only incentivize, they incentivize the use and the constant use of the Dutch exchange once you're on there, but not only can you reduce your fees, you can also get some share of the fees. So, okay, we all know why decentralization is cool. Let's go through why this particular auction mechanism is so cool. So it's a neat mechanism to find a fair market price. So basically, the best strategy of any buyer is to buy at their willingness to pay, because they will receive that price or better. So you won't have something that looks like that, which is like an order book of another decentralized exchange, where, I don't know, I think this bar is an hour and a spike of, I think, 8% in price. So all the sellers taking part in the same auction will also get the same price. So there are some more benefits. Let me run you through them. And we've had front running quite some time. So front running is when anyone makes use of information that they obtain beforehand to fulfill an order or place an order before somebody else's information is processed, right? So on this particular, because everybody will receive the same price of all the buyers, there is no front running from miners, exchanges, relayers, as we heard before, or any other participants. So the matching is done with a single price clearing on chain. the other smart contracts can use the Dutch exchange because everything is done on chain, and there's no off-chain signing or what else? Yeah, there's no, and you don't need a strategy to participate because there's only one strategy. So we are also a reliable, or we would like to be a reliable on-chain price oracle, which means that we would like to provide a price feed, because obviously the prices won't be that volatile because the price is only found every, say, 6 hours. And there's no risk of multiple traders trying to fulfill the same order as you would have in other decentralized exchanges. And it looks, for example, like this, where you can see that these orders are not fulfilled, but transaction costs are still incurred anyway. Some more benefits. So because we batch together the sell orders, it's quite a good and efficient way for illiquid market, because it's a period of time where we accumulate all the orders coming in. It will be for sure less volatile, and also because, so basically the way you can imagine is the seller kind of puts in a market order and the buyers put in limit orders. So I don't know, traditionally on order books, if you were to put in a market order, it could very well be that you buy off the whole order book, having like spikes in the order book and in the price. So that won't happen here either. It's also cheaper than most on-chain matching because, well, obviously you incur gas costs, but there are no cancelled orders, or you can't cancel orders. So there are no gas costs incurred for cancelled orders. So the Dutch exchange contract matches automatically and on-chain. So there's no trust needed towards this exchange because everything is done on-chain and automatically by the smart contract. Okay, so some decentralized exchanges have the difficulties of matching a market order with multiple limit orders. That's also not the case here. And obviously what's very intrinsic to our model is that you can make use of the fee reduction system and also the fees remaining in the ecosystem. Cool. Questions? Really quick.
Yeah, so I think it's only fair that I jump on the stage and I'll pass around the mic here. So it all seems cool and it prevents front running. My question to you is, what's really the upside from the seller side and what's the upside from the buyer side when going into such a Dutch auction?
So basically we kind of see different user groups as the seller and as the buyer. So obviously you can be either one, because either you're doing A, B, or B, A. You can participate as either one, really. But for the seller, we're targeting to have like a very simple interface for anyone to really just be like, look, here are my tokens. I don't really care that it takes 6 hours or maybe longer. Just I take the fair market price that I'm getting. And for the buyer, and they also obviously can make use of the fee reduction and the tulip system, but for the market makers, which likely will be acting as buyers, obviously the great advantage is they only participate when the price is right for them, right? So they can potentially factor in the fees they would need to pay, and they're guaranteed either that price or lower.
Yep. Got the front.
Hi. Maybe I didn't understand the system, so if it's so, ignore my question. But so the auction starts, and the market, this is a very volatile market. Mm-hmm. So the price of what I want to buy for me is X. And after 2 hours, the token I want to buy drops. At 3%.
Yeah.
And but I put my order in there at a certain price, so if during these 6 or 12 hours, like I saw in the graph, the market changes significantly, how does it work in that case?
So basically, you're right. You're absolutely right. It can be very volatile. So kind of as a seller, you'll be getting the fair market price at that point in time where the auction clears. So there is kind of, you don't know exactly what you're getting beforehand, but it's not meant, so user groups kind of exclude high-frequency traders. So whoever wants to skim the market on a minute trading, this is not the way to go. So it's more like a price discovery of the fair price, really, than the whole volatility. So we're actually, it will be a more robust price feed actually in the end. And so as a seller, you're right, you're getting what you have in the end. But as a buyer, you participate actually at that point in time where you think the price is right, and you're guaranteed to have that or more. And as a buyer, actually, you can already withdraw your funds at the point that you're buying, and then any kind of increments until the auction closes. So as a buyer, you don't really have that risk. Does that make sense?
Yes, but I had also another question which came up. And
come find me after.
Hi, just back here. Yeah. What's to stop collusion? So you mentioned about the buyers getting together. What's to stop collusion, that a bunch of people get together and drive the price down?
Yeah.
Here.
Yeah, so it's based on an economic incentive, basically. So yes, you could collude, obviously, but there will be somebody else out there for whom it's then beneficial to buy because they're guaranteed that price or less, right? I mean, it's based on really that economic incentive. Sorry? Well, only if the collusion is so likely. Obviously, this will not be able to happen because somebody will always cheat the market and get in there to get that arbitrage, right? So if the obviously there is a risk that there is a market failure, but if there is no market failure, then the seller at that point in time will get a fair price. Yeah, so the price function is designed so to give justice to the volatility. That's why it starts at twice the price of the closing function before. Then it drops quite quickly, and then around the critical points it flattens out so that buyers have enough time to actually be active around those price points. And then, I mean, you could do it quicker as well, you could do it longer as well, but there needs to be some kind of, middle way.
But there's absolutely no flaw for the seller. The seller is always fully committed for the coins he's actually.
Well, yes, but it would be a massive. Well, the floor is 0, but yeah. Yes, you're right in that sense, but also we run A, B, and BA at the same time. So when we reach 6 hours, then it's worthwhile to do arbitrage between those two markets, right? And also, I mean, theoretically, you're right, there's no guarantee, but at some point in time where the price drops enough, a buyer will buy. And the thing is, we can't just run it for any kind of liquidity. So we have a liquidity cap. So there's at least $1,000 worth of sell volume in there to give also incentive for the buyers to be active. Obviously, if there's nothing in the auction running, then there are not enough buyers willing to buy.
But isn't it a buyer's game in advantage of any buyer?
Why?
Just assume the sell price would be already a bit down low, so after 5.5 hours it would be at the end of the curve. Buy the market swing in the next 10 minutes would be very high up. So the next bidders would actually get a very cheap trade. That is not exactly what I understand as a fair price.
I'm not entirely sure what you mean. So the curve goes over 24 hours. Around 6 hours, we're at the old price, right?
But the price is a very fancy concept, isn't it? We have a lot of exchanges.
Yeah.
It's like saying ERC20 token will be sold the same instant of time.
Yeah.
Probably it would be fine.
Yeah, so we assume, and if there are any market makers out there, please come find me afterwards. There will be market makers who will use the arbitrage to other exchanges for it to provide liquidity on the buyer side.
What will happen is actually if you have price swing upwards,
Yeah.
but you already have locked in a price lower than that for your 6 hours auction, everybody will do the arbitrage and jump in for the remaining amount of money, and the seller is kind of, well, he actually sold at a lower price as potentially fair price at the point of time when the auction would be.
well, but they committed 6 hours ahead of time, right?
But that's the problem. You have liquidity, you have liquid prices all over. So I understand your argument that in a completely illiquid market, where price discovery is not present, the Dutch auction system makes a lot of sense. But in liquid traded assets or coins, there's an asymmetry in terms of chances in the system, if you understand.
Well, the seller is not the one making advantage of like a high-frequency trading and skimming the market. It's really somebody who would want to exchange A for B on a more long-term vision rather than, okay, now the price has fluctuated 10% again. So it's more like a robust price feed, actually, rather than taking out all those fluctuations.
And so the mic is here. I have a problem to see the average user or who would basically use it, because right now traders want to have instant trades, and if you want to pay something in crypto or you want to have a token to use a service, it would take a long time to get it or to pay with it. So what is the average user for you?
So the seller can be anyone, can be also people who are not necessarily deep down in the blockchain space. But for the buyer, so the buyer can actually withdraw their funds immediately. So as soon as the price is right, that will get translated into the exchange, well, what they get, and they would then just get, until the auction closes, all those increments, right? So it is actually quite, for the buyer it's liquid. The only disadvantage is that they have to participate at the exact right moment in time.
Thank you, Chris.
Could you explain the token economics, please?
I think we have to move on to the next speaker, but
Find me afterwards.
Come on.
Chris should be easy to find. She's also local in Berlin. So. Coming in from Singapore, we have TN from Kyber Network.
So good evening, everyone. My name is Tian, and I'm from Kyber Network. It's a great pleasure to be here. It's my first time in Berlin, and it's really nice to be able to connect to the Ethereum or blockchain community here. So yes, I think to begin with, I want to start off by saying that exchanges are typically the central body that allows the transfer of value from one individual or party to another. And so it becomes, I mean, in other words, exchanges have become a very integral part that allows us to grow as a sector. So, so today, other than Kyber Network and overview, I'd also like to talk a little bit about how decentralized exchange like ours can coexist with centralized exchanges. Because when we started out, a lot of people, they were commenting that if decentralized exchanges are going to rival centralized exchanges. But as most of us know here, our industry, our sector is just growing too rapidly, and there are certainly spaces to accommodate different types of like different players in the same space. So, and in fact, most of the time, because things are growing so fast, we have to look to collaborate in order to scale, or otherwise we can't cater to the demand. So, I think to start off, I just want to say that Kyber Network is a decentralized exchange service that allows seamless and secure token conversion with guaranteed liquidity. So that means that if for any kind of token conversion that happens on Kyber Network, it is really fast. It is it's block instant, because we run reserves at the back, and that's how we make sure that we have the capacity to support the different transactions. And I think beyond that, we are also motivated by the objective of be the enabling agent to support crypto transactions between individuals and organizations in the blockchain sector, so that everyone can realize the full potential of the blockchain economy. And by design, Kyber Network is a secure exchange because everything runs on chain, and all the interactions between the stakeholders within the network are done by smart contracts. So on top of that, The transfer is also instant. So users can literally send and receive tokens in a single transaction. Now, the other thing is that we value very good user interface and experience. So we try to be as transparent as possible. So that means that we don't have hidden fees. And typically, like for users, what they see, there's only one single price. That's the price that they're going to pay for. And of course, we're a very liquid platform because we start off by committing a huge amount of fund to the reserve. And that's one of the strongest propositions for our Kyber network. So having said that, now the question is, how do we deliver the 4 propositions that we've promised, right? And there are basically 4 parts. So the first part in building Kyber network is to make sure that like we run everything on chain, because by having the entire exchange on the Ethereum blockchain, we make it decentralized and we ensure the highest security for all the different types of transactions that happen on our exchange. And then we decide to remove order book and introduce the concept of reserves. So when we were brainstorming the kind of design for architecture, we felt that we decided to do without order book, unlike most other exchanges, because to run order book entirely on chain can be very expensive. Because as a user, if you want to do any modification or adjustments to your order, you're going to have to incur additional costs. And then we also introduced the concept of reserves because we want to cater to the liquidity on chain. Again, when we were doing our brainstorming, we realized that there are already existing decentralized exchanges, but they're still not able to compete against centralized exchanges. Now that means, and then we attribute it largely to the fact that a lot of these exchanges do not have the liquidity. And it makes sense because if you don't have the liquidity on the exchange, an order takes a much longer time to get fulfilled. And nobody likes the waiting time. So we decided to introduce reserves so that we can support transactions much more readily. So after that, with the idea of having reserves on chain, then it is important for us to bring the market makers on chain, right? Because these market makers, they can support the network by providing liquidity of the tokens that they desire. And then the incentive for them to do so is that they get to profit a spread from the transactions that they support or involves their reserves. So Kyber network is going live on mainnet in a few weeks' time in February, and in the beginning, at least for the first 2 months, Kyber network will be the one of the 2 reserve operators within the network. So we've raised a decent amount of Ether during our token sale, and we'll commit half of it to the reserve. Okay, so having dealt with the supply side, which is the liquidity side, and then we think about how to increase the demand for our platform. And that is where we think about integrating Kyber network with wallet providers and service platforms. So we favor a B2B approach at this moment, first and foremost because there are already a lot of wallet providers out there that are doing excellent job in UI UX, and we don't really want to compete with them. Then on top of that, we don't have the depth and the experience to onboard that many customers. So it would be in our best interest to use our approach to support the operations of other providers, wallet providers and service platforms, and power the exchange function within their application using our unique approach. And so wallet providers aside, the service platforms here in considerations are mostly the blockchain platforms, right? Because typically for a lot of these blockchain platforms today, they only accept their own native platform tokens or currency as a form of payment. So that means with Kyber network integration, they no longer have to restrict their user base to just the token holders. That means users that are interested in utilizing their platform can pay in any desired tokens as long as Kyber Network supports, and then Kyber Network processes the transactions. The platform still receives the payment in its native currency. Again, put it this way, from a user's perspective, today, if I were to use any kind of, if I were to use a blockchain platform, I need to possess the token. Then I have to go to an exchange, acquire it, and then pay it to the exchange, to the platform. But with Kyber Network integration, all the user needs to do is go straight to the platform, make the payment in ERC20 token, Ether, or whatever. Kyber Network processes the transactions, and then the platform still receives the payment in its native token, right? So we're trying to bring down the kind of obstacle or barriers for people to enter into the cryptocurrency market. I've prepared like a short video about the integration, but I think I'm going to skip it. In any case, this is a video of Kyber Network integration with IM Token, which is the largest wallet provider in China. Yeah. So wallet provider aside, we're also ready to integrate with service platforms. Some of our partnering platforms are like Wax Request Network, and that means with Kyber Network integration, anyone can pay with their own desired token or currency. Kyber Network processes the transaction, and the recipient still receives the payment in its desired token instantly. So now I would like to give a more macro aspect of Kyber Network as an exchange, and this is largely how Kyber Network can exist alongside other centralized exchanges. Again, this is like a very basic framework of Kyber Network. So on the left side here, it comprises of the requester or the demand side. So the demand side is, it comprises of individuals that require token conversion service, or wallet providers or service platforms that I just mentioned. And then Kyber Network falls in the middle of everything. And then on the right side, there's the supply side, the reserves. So these are the liquidity providers of the network, and they are managed by a group of managers. And then the last group on the network is a group of operators. So these operators are responsible for keeping the integrity and discipline of the network, and they are also responsible for listing and delisting tokens. So there are two ways in which Kyber Network can work with centralized exchanges. So the first one is because we need a sizable amount of token holdings or cryptocurrencies in the network. So exchanges, they can set up reserves within Kyber Network and run them as reserve managers. So beyond that, Kyber Network also can work with centralized exchanges for the rebalancing acts after, just to make sure that the tokens within the network stays at a target level. So I think to illustrate the importance of reserve, it would make sense for me to go through the function of a reserve, and how it plays a part in the whole framework here. So I'm just going to use an example to help with the understanding. And typically, when there is a request for a token conversion, a user submits it to a Kyber contract, and then Kyber contract takes it directly. So in this case, the example shows that the user wants to offer token A in exchange for token B, right? So as soon as Kyber contract receives the order, Kyber contract looks into the reserve and choose the ones that with the best rate. So for simplicity's sake, we're just going to assume that there are only 3 different reserves here that offer token A and B at the same time, and each of them has a different price. So again, using the example in the diagram, Kyber contract recognizes that reserve 2 offers the best rate. So Kyber contract will choose the token from reserve 2 to support the transaction, and then subsequently, reserve 1 and 3 will not be able to participate in the said transaction. So, as soon as the reserve is identified, contract will take the token A from the user and deposit it into the reserve, and at the same time withdraw a corresponding amount of token B to the Kyber network, the contract, and then sends the token B across to the user. So this pretty much sums up the relationship between a requester, Kyber network in the middle, and the reserves. So these reserves can be either individuals or organizations with large token holdings, or even centralized exchanges or exchanges with their own tokens. Yeah. So I think to add on to that, the benefit of becoming a reserve is that it could be an additional revenue stream for the exchange, because the incentive for people to participate as a market maker is that they get to profit the spread. Yeah. And then, of course, because Kyber network integrates with different types of platforms and wallet providers, we can offer an avenue for the exchanges to reach out to different groups of users. Again, a lot of these funds that we're targeting are usually sitting idle. So what we try to do is to create an avenue for market makers to generate revenue with the funds that are otherwise idle. Yeah. Again, so beyond just being a reserve, we also need help to rebalance the platform. Again, just for illustration and a follow-up with the example earlier. So after the transaction with the reserve, second reserve, right? Now, second reserve will have more token A and less token B than before the transaction. Okay, so part of Kyber network's mechanism is to do the rebalancing and bring the level of tokens within the reserve back down to a target that is set forth by the reserve manager. So in this case, because there is an excess of token A and a deficit of token B, so Kyber network will first perform a rebalance act within the network, and then after the consolidation, if there still exists a deficit of tokens or surpluses of tokens, then the surplus will be sold to other exchanges, or the deficit will be purchased to replenish within the network. Yeah, so in a way, this kind of relationship helps promote the transactional volume between the different types of exchanges. And again, just to consolidate, I've pretty much gone through like an overview of Kyber network and the two ways Kyber network can coexist with other exchanges. So yeah, that's pretty much the end of it. Thanks.
Okay, so I was just told that we do one question me and one question from the audience because we're short on time. So my question would be, and I can also simplify this for the others, is Kyber network basically focuses on high net worth individuals and basically people who are running bigger funds. Sorry. So my question to TN is, when can actual small-time traders participate? Because you also do KYC for these bigger exchanges, right?
Right.
So when can us, the normal peeps, participate, and how would that look like?
So, well, to address the question, I have to start off with saying why we choose to do with the bigger funds first. Because Kyber network being the only reserve operator in the beginning, we're dealing with a small number of users. At the beginning, we don't see us like we're just gonna cater to about 40,000 people in our pilot launch, and then we try to increase the the invites to different groups of people over the next few weeks. So it makes sense for us to go for the larger funds, because when we're talking about committing funds to the reserve, it typically takes a period of time. So you have to commit it to the reserve for, let's say, a period of 1 or 2 weeks, sometimes maybe longer, depending on the demand and supply of the tokens. So the thing for us is that we want to be compliant with regulation. So we will conduct KYC checks KYC checks on all the reserve contributors. So and of course looking at the source of funds as well. So if we have like a smaller number of people, but they're able to provide a much bigger liquidity pool to the network, then it makes sense for us at this time, because we don't have the capacity to cater to that many people. So we conduct the checks on the representative of the organization, and then know about the source of funds, and then they, at the same time, because they are verified, they can provide a much bigger liquidity to Kyber network. So compared to the smaller market makers, if we have to do many checks, but the provision of liquidity to the network is relatively minimal, then it wouldn't make too much sense for us financially.
Cool. Someone in the back? The back is pretty inactive. Or the left side? Oh.
So just to make sure that I understood you correctly, so through the reserve system, you want the already centralized exchanges to compete with each other to offer the most liquidity for the different tokens, right? That's my first question. Can you answer that affirmatively, or?
Well, we try to we try to be agnostic, so it doesn't really matter whether it's centralized exchanges or not, but we are providing an avenue for centralized exchanges to participate in the network, so that they get to, it's an additional avenue for to generate revenue there.
Right, and do you see the danger of centralization there? Because, yeah.
So I don't really think there's a centralization issue over here, because what we try to do is to promote competition. We want it to be, we want our reserves to be able to provide competitive prices so that our users benefited. Right? By having different liquidity providers, even if they are providing the same, so for each token type, the more reserve provider there is, supposedly the price should be more competitive, and that is what we try to attain here.
Thank you, Tian. All right. We've got Hansen and Gautham coming from Zug, Switzerland, to talk about Melonport.
Check, check. First of all, thank you to the team of Web3 for hosting this wonderful event. It's an honor for us to be sharing the stage with some of the best minds in the industry. And also thank you all for coming today. My name is Hansen. I'm the head of external relations for Melonport. And I'm here today with my colleague Gautham Nekkanti, who is one of our lead blockchain developers. And together we're going to take you today on a little journey through the world of asset management, through the viewpoint of a small blockchain company. Okay, so we are in the business of asset management, yeah? In the business of managing assets, managing money. In fact, actually, if you are invested in cryptos or stocks or bonds or really anything, you are in a sense an asset manager yourself. But many of us, we don't have the time nor expertise to find good investment opportunities ourselves. So what can we do? We can find a trusted investment professional, and we let them manage the money on behalf of us for a small fee. And asset managers, they have been managing other people's monies for many years, and most of the time it goes well, and sometimes it goes bad, and other times it goes really, really bad. And the last time that it went really, really bad was in 2008, as I'm sure most of you remember, during the last global financial crisis. And you know, I saw in the newspapers, the Queen of England, she asked a funny but important question. She said, given that the financial crisis was so big, how come everyone missed it? Yeah? And it's a good question to ask, right? How did everyone miss something as big as a financial crisis, which affected virtually all of us? And I think that something as big as a financial crisis, you know, wasn't foreseen because of two main problems, you know, in the asset management industry as a whole. One of it is, number one, is an inherent lack of transparency in the industry as a whole. We don't really know what investment bankers do with the money. We can't, you know, see into their databases. And the second point is that asset management has a very high barrier to entry. Yeah, it's usually quite exclusive to a select few. I used to work in investment banking for 3 years. We often wouldn't even take money from people which was less than 100K, because just too much effort to organize everything. And I think that if we would, you know, make the asset management industry a bit more inclusive, we could have maybe even foreseen the financial crisis or even, you know, prevented it. And that is actually what we are working on at Melonport. We are working on solving exactly these problems. We are building a fully decentralized tool for people to set up and manage their own fund, investment fund, in digital assets. And the decentralization will help to drive down the barriers to entry drastically. And we are using blockchains to bring some long overdue transparency and also efficiency to the asset management industry. And actually, before I start talking about the architecture of our protocol, I want to say a few words about the rationale behind why we do what we do. We are an open source project. You can see our code on the GitHub. And the Melon protocol is also intended as a public good, like the internet. Yeah? So I get many emails every day who ask us, you know, what can we do to set up a fund on the Melon protocol? And the answer is, you don't have to do anything. You don't have to ask us. Yeah, we don't own it. The Melon team is building the Melon protocol, but once we are done building it, we're going to take a step back, and then we're going to roll it out to the people for free. Well, it's not completely for free. If you have to pay gas if you call functions on the blockchain, but that money goes to the miners, the stakers. The Melonport team is not getting a single cent. Okay, so let's look at the architecture. Yeah. At the core of our design, you have the Melon Fund. This fund is a set of smart contracts, and you can kind of imagine it like a wallet, but it's a very, very sophisticated wallet. It has far more functionality than just sending money around. And when you decide to set up your own investment fund, what you do is you first choose the parameters of your fund, right? You choose which exchanges you want to trade on, what the asset universe is, what risk management module you want to use, how much you want to charge your clients. And once you chose all those parameters, you will deploy the fund on the blockchain, and then you can only behave as you specified before. 1 second. Yeah. Sorry, I was a little bit nervous. And once you set up your fund, right, and you deploy it on the blockchain, you can then directly trade from the Melon IPFS front end with all the exchanges. And the people, they can openly see how you're performing. If you're talented and if you have good performance, people then can invest in your fund. All they have to do is they go to their own wallet and they send, let's say, 10 Ether to the public address of your fund. And you as an investment manager can then use these funds to invest, to trade. So let's say Gautham sets up a fund, and I know Gautham is a great trader. I can send my 10 Ether then to Gautham, and he can make the asset allocation for me. But we designed the protocol in a way that he can never run away with the funds. Yeah, I'm always in charge of my own private keys. The smart contracts, they also take care of all the accounting. And it's very scalable. Yeah? You can have as many investors as you want in your fund. And the smart contracts will automatically calculate exactly how much each investor gets from the profits based on how much they invested and when they invested. And they also automatically calculate all the fees. And I mean, if you want to try it today using the current infrastructure, to set up a fund and have the entire room of people investing in your fund, you would have to need an entire back office and operations team to do that. And we are replacing a majority of them. We're currently built on the Ethereum platform, which means that you can only trade ERC20 tokens in the current implementation. And don't get me wrong, there's many great ERC20 tokens out there, but it does feel a little bit restrictive, especially if you have our vision in mind. Our vision is we're going to see a vast movement towards the tokenization of real-life assets as well. And there's many teams already working on that, right? Maybe soon you won't buy an Apple stock anymore, you'll buy an Apple coin or Nike token. And when that day comes, there's also going to be a new wave of asset managers. And we don't know who the next George Soros or the next Warren Buffett is going to be. But what we do know is that the next rock star in investing is going to be using the Melon protocol to manage their assets. But in order to do that, we need to expand our current asset universe from just ERC20 tokens to a far broader range of tokens, right? And I think at this point, I'm going to hand over to my dear colleague Gautham, who's going to give you a sneak peek of one of our solutions to integrate not just one blockchain, but many.
Thank you, Hansen. I'll take it from here. So, for people who don't know, good evening, everyone. I'm Gautham. So, for people who don't know about cross-chain exchanges, let me give a short overview. So, cross-chain exchange is actually a implementation of an exchange that involves trading of tokens that belong to different chains. So the pre-mandate for that is that the user need not leave the chain he is native to. So for example, if you want to trade your Ethereum to Ethereum Classic, don't do it. But if you want to do it, you need not leave your have a wallet or client on Ethereum Classic. You should be able to do it on Ethereum itself. So for this, this is the concept of cross-chain DEX. So what's the need for a cross-chain DEX? So let me start by giving our own use case. So we at Melonport have decided to start moving to our own domain-specific chain called Melon Chain. So this is due to different reasons like scalability, security, and domain-specific blockchain operations. But so it's although we are quite popular, but to be honest, we can't expect different assets, like that many assets, to exist on our own blockchain. So it's kind of restrictive, and it's going to be a huge deal breaker for asset managers if we are going to have this restriction. So they should be able to trade any kind of assets like ERC20, Bitcoin, Ethereum Classic, whatnot. So this is why it's important, like cross-chain exchange is important to us. We also believe that future of blockchain is going to be multi-chains. So there are going to be a lot of use case, lot of projects that are going to have domain-specific blockchains, and they are going to move towards that. So this is one of the areas Polkadot is working on. And so the current decentralized exchanges only support ERC20 tokens of native chain. So it's going to be they don't support cross-chain, of course. So one way we are going to, we have in mind is to have a token bridge. This is a component that allows free movement of tokens across different chains. So this is this is basically a smart contract that exists on different chains. This smart contract allows tokens to be replicated across chains. These tokens are called mirror tokens. So these tokens, the original tokens can be faithfully be deposited to the main, this contract, and you can specify the chain you want it to be replicated on. So the relayers, there's going to be a mechanism called relaying that has a set of relayers they are going to relay the your deposit transaction, and the mirror tokens, the same amount of mirror tokens are going to be minted on the target chain. So there's a cryptographic guarantee that these mirror tokens can be faithfully be exchanged for the original tokens, and this guarantee ensures that these mirror tokens have the same intrinsic value as that of the original tokens. So this alone, the bridge alone isn't sufficient for a cross-chain exchange, because you still need to maintain different clients on different blockchains if you want to replicate and trade on that specific blockchain. For this reason, we have developed a concept called settlement logic for this exchange that is going to use this bridge. So when you create an order that involves assets of different chains, then this order information is first relayed to the other chain. The other chain is the chain where the other asset lives in. So this one, once a counterparty or the other party who finds your order price attractive and takes the order, which is order matching, then the tokens are deposited and relayed using the mechanism, the bridge mechanism, and the clone tokens or the mirror tokens are assigned to the parties accordingly. So let's see this by taking an example. So Bob wants to exchange his Melon for his Augur rep tokens. As you know, Melon is native to Melon chain, while rep is native to Ethereum chain. So first he starts by depositing his Melon tokens on the Melon chain, and he makes an order by specifying the parameters like the price and by asset. So Alice, so this order is first relayed by the exchange operator to the destination chain, which is the Ethereum chain. That's where the Augur rep tokens live. So Alice on Ethereum chain sees this order and takes this order by depositing her rep tokens into the bridge contact. So once this is done, the relayers relay the deposit transactions on both sides, and the mirror tokens are assigned accordingly. So mirror tokens, rep prime is the mirror token, which is minted and assigned to Bob, while Melon prime is assigned to Alice. So the current status of a project is still in prototype, and we actually have a contract for the bridge, which is modified version of parity bridge contract, and we also have a simple market that implements the custom settlement logic. So it currently consists of a predefined set of authorities, which isn't completely decentralized, but we are going to fix that in the future by connecting to Polkadot. So in Polkadot, the validators are going to take the place of the authorities. So we can actually use the ERC20, use existing ERC20 tokens, but for mirror tokens, we need a new standard for interoperability. So this is going to be a simple extension of ERC20 with just two functions called mint and burn, which some ERC20 implementation already have. So what are the benefits? So obviously the benefits are ability to trade across chains, and of course you're going to have a much better UX that user need not leave the chain he is resident to, and you can share, because the orders are aggregated across chains, there's going to be a lot of liquidity across chains, and it is also exchange implementation agnostic, so you could use 0x, Kyber, whatnot. All you need is a simple extension to the settlement logic that should use the bridge. So one important factor we need to consider is security, because you're dealing with multiple chains, and not all chains are created alike. So there's probably going to be a chain that's going to have lesser security and maybe compromised. We need to consider that. So in this case, our system design is done such that the original token holders do not get affected even in the case of a compromise. Future integration with Polkadot also ensures that integrity of foreign chain state transactions.
All right, there was a short overview of the Melon project and our solution to integrate cross-chain exchanges. I think we have a bit of time for some questions, and if we don't have time, Gautham and I are going to be around over there. Just find us afterwards as well, yeah?
Yeah. So my question to you would be it's a pretty simple question. What's major problem that's you have to fix in order for the Melon protocol to be widely adopted in the future?
Absolutely, yeah. Good question. I mean, we are working with bleeding edge technology here. There's going to be many obstacles along the way. If we had to choose the main problem, I can't say one. I'll say two. Okay, there's two main problems. One of them is technical, and one of them is regulatory. Let's do the technical one first. I think that's easier, and not easier to solve, easier to understand. The current financial services industry handles tens and hundreds of thousands of transactions per second, yeah? And if the Melon protocol wants to take a substantial share of that, we need to scale the blockchains, to an extent that they can handle similar amounts of traffic as, the centralized counterparties can. And they really currently can't. I don't know, how much can Ethereum do? 20 per second? I'm not sure. That's the first obstacle, but we have many capable people working on that. And the second obstacle is the regulatory side, yeah? We're currently operating in kind of a gray zone. Regulation is not very clear. We're not opposing regulation, yeah? On the contrary, we're actually in favor of regulation. Regulation that's effective and that accommodates the new needs that arise from this new paradigm. The old model doesn't really fit. And that starts with custody, for example. So if I was to invest in a hedge fund, I would send from my bank to the custodian bank of a fund, for example. And the bank oversees all activities, and if anything goes wrong, the bank is responsible. But in our case, right, in the Melon protocol case, I'm sending money to a smart contract. And if we assume, yeah, which I think we did, we wrote the code for the smart contracts correctly, it's also very safe. But the regulators have to get their head around it, yeah, and also investors actually. I'm not sure if some old veteran from the fund industry will be comfortable sending 30 million into a smart contract. But we're also working on that. In fact, last year we founded an association called the Multi-Chain Asset Manager Association, together with MME and Bußmann Advisory. And yeah, we're getting together, every big player who's working in blockchain asset management to implement, industry standards and best practices, and working together with the regulators. Because we think it's really, the people that actually work with the blockchains should have a say in how the regulation is shaped, especially because we understand it better, and it shouldn't be like JP Morgan and Goldman Sachs who just decide on that.
All right.
Yep. So I think we have to cut it off now.
Yeah. But we're going to bring up from Web3, Matt Ferrante, to talk about his decentralized exchange and some privacy-preserving exchanges.
Cheers. All right, so I'm Matthew Ferrante, speaking on behalf of Web3 today. My talk's a bit significantly more technical than all the previous talks before, so wake up. Unfortunate that it's the last one, I guess. But the topic is privacy-preserving exchanges. I'm not really talking about a product here, more approaches. Some of the stuff is R&D work that I've been doing in the past few months. Some of it exists, some of it exists as code on GitHub, some of it is still very researchy phase. But I'm going to be talking about two main approaches today. I hope everybody can see this. Either way, I'm going to enunciate it as I go on. And two main approaches are sort of ring signatures, which are kind of known now in the blockchain space. As an example of like a ring signature system that already exists, that would be Monero. Though Monero uses passive ring signatures, meaning that people don't have to be aware of the fact that they're being used in a ring for privacy reasons, whereas most of the exchange versions would have to use active ring signatures, so I'll go over that in a bit. And the second main approach is the zero-knowledge set accumulators. I don't really think a talk on that has been done yet outside of academia,
So, bear with me with that. Anyway, so ring signatures. Some of the background on ring signatures. The concepts were first introduced in a paper titled How to Leak a Secret by the RSA authors. It concerns using keys in a group instead of using them individually to prove you have a private key from the group as opposed to proving ownership of a specific key. So, for example, actually, one of the nominal examples, which is why this was invented in the first place, is for whistleblowing. If each public key, instead of the public key being related to like a Bitcoin address, it's related to sort of the email address of some politician or government official, the official can leak some classified data, proving that they are indeed a government official, without outing themselves individually as a whistleblower, right? So say that there's a set of keys the ring, that belong to the Department of Defense, and one of them leaks data that you have a signature over the entire ring that signs a message that says, I don't know, some of the funds in the Department of Defense have been embezzled, and I'm sure, I've just been blacklisted from the U.S. for saying this, but yeah, it's you get the assurance that only somebody from that group could have signed that message, but you have no idea which one, right? So, and if you extend this to payments, I'll show here, you can use it in privacy preserving exchanges. But say, ring signatures are a type of zero-knowledge proof, and so it's more deeply into how they work. So they prove zero-knowledge proofs in general, which applies both to ring signatures and zero-knowledge accumulators. Basically say they prove the knowledge of a secret without revealing anything about the secret, right? So it should be one knowledge because you are proving one thing without revealing the entire component. But an analogy that I like is quite easy to understand if you don't have a background in cryptography, is say that I choose a card from a deck of cards and I want to prove to you that it's a red card. If I just show you that the card, it reveals more than the color. It reveals the suit, the number, and whatever else the card has on its face. If, on the other hand, I just take my card aside and flip up all the 24 black cards, say that there's 40 cards in this deck, and 24 are red and 24 are black, assuming that there are no more black cards, such that it's like a packed deck, I've proven that the card that I've set aside is red, right? So the zero-knowledge proof in ring signatures is called a zero-knowledge proof of set membership. So there's a signature, a normal signature from normal elliptic keys, normal elliptic curve signatures is called proof of exponent because your private key is an exponent, it's just a number, and your public key is generated from that number, and a signature uses both those two numbers together to create a signature. So by signing something in normal elliptic curve signatures, it's a proof of exponent. This one is proof of membership. So I have one of the exponents in the ring, right? And there's many types of zero-knowledge proofs. But so this is the second most non-trivial one. So how can this be used for privacy-enhancing exchanges? So for example, say that you have either a centralized exchange or a token that allows you to trade assets, or even a decentralized exchange, and you want to make sure that the people interacting with your contract are not terrorists, or that at least you have gotten a certain level of authentication from them, but you don't want it to fall, you don't want that authentication to reveal everything, right? So in the ring signature example, this would allow you to say you have a bunch of users, and these users go through, like say Alice, Bob, and Sarah, right? 3 users. These users go through an authority that does know your customer verification, and when they, once they check that you're not a terrorist, you are who you say you are, you're allowed to transfer this asset, whatever that may be. They take your public key and they throw that into the KYC'd ring smart contract. Now, this could be, this whitelisting process could be whitelisting them in terms of buying a token from a token sale, in terms of trading at a decentralized exchange or whatever it is. And now the users can, from different Ethereum addresses, if we're using Ethereum, provide a signature and interact with this contract without revealing who they were in the set. So this user could be Alice, Bob, or Sarah. This user could be Alice, Bob, or Sarah. And so a regulator or somebody who's externally looking at the blockchain only knows this is one of those users, but they just do not know which it is. But at the same time, they know that it could be one and only one of those users, right? So it kind of gives you a similar, it kind of gives you like more similar security and privacy properties that you have with, say, a bank account in cash. If I go to my bank account and I withdraw the money, like from an ATM, and then I go to Pret, and we're in Germany, so I go to some food shop, and I buy food. Like the bank doesn't need to know that I took out those 10 euros from the ATM to buy a coffee with them, right? The bank only needs to know that the bank only really cares that I'm not a terrorist, right? And then they allow me to withdraw money from the ATM. The food shop doesn't care where you got your money from. All they really need to care. Well, actually, they don't really need to care about anything. But as long as you're not going in and shooting up the place, right? So you have these. It has more similar privacy properties as to what you are used to in real life. The bank, once you withdraw money from something, and you have authenticated with the bank, with your provider, they don't really need to follow your entire lifestyle trail, right? So it's similar here. You authenticate with a provider that allows you access to an ecosystem, and as long as you stay within with that authenticated ecosystem, nobody cares. Nobody should really care whether it's you, Matt, that bought the coffee versus, just some citizen allowed to be in Europe bought the coffee, right? So it's nice to, and it's something that without this special cryptography is not really possible, but it's quite scalable, and it's secure. In terms of security, it's not even that fancy. If you trust the security of elliptic curves, meaning if you trust that Bitcoin and Ethereum aren't just going to collapse tomorrow, this is about the same level of security. Security, they're not about to collapse in terms of the cryptography, right? I'm talking about the price. Here's the interaction step. A user has one of the public keys and the ring R, and the contract has the ring consists of this array of public keys. And you have the message epoch, which is kind of like a nonce. The user generates a signature over the ring and the nonce and sends it to the server or the smart contract with the action that they want to perform. Transfer a token, perform a trade, blah blah blah. The contract replies with success and computes the unique tag from the signature and accepts. If the user now tries to double spend or perform another action that they're not entitled to over into this ecosystem, the contract can detect that, which is one of the nice things about this extension to ring signatures that can be used on the blockchain is that it prevents somebody from looking at your signature on the blockchain and taking out the bit that is needed for authentication and replaying your authentication, right? So this can't just be used for trading and payments. It can be used for anonymous voting, where say that we go to the government authority and each of us submits a public key. Then where there's a voting round on the blockchain, and each one of our public keys is in that allowed voting ring, and we perform a signature over the ring such that when I vote, you have no idea who voted, but you know that it's somebody whitelisted, right? So these ring signatures are quite nice and quite general. So that's it on there, and so I'll move to the zero knowledge accumulators, which is another way of doing similar things, but also I was listening to some of the questions earlier on, and this is also quite a big one for scalability, and I'll go into that why that's in a second. But I'll read that out for people who can't read. So for people who can't read from where they are. So a static cryptographic accumulator scheme allows to accumulate a finite set X into a succinct value accumulator sub X, the so-called accumulator, for every element X, subscript I, that is in the finite set X. One can efficiently compute a witness, so-called witness sub Xi, to certify the membership of X sub I and accumulator sub X. So, however, it should be computationally feasible, meaning practically impossible, to find a witness for any non-accumulated value Y that is not in X, so collision-free. So, more English terms, what that means is, you have this value called accumulator X, and this is kind of, if you look at it, if you make an analogy, it's kind of like the result of a hash function, right? If I have a hash function that is, if I have like 10 different numbers, and I put all those numbers together in a box, and I hash that box, I hash that array, I get a constant size value, right, which is 32 bytes, if it's like SHA. And if I give you all those numbers again, you can verify that like those 10 numbers correspond to that SHA hash, right? But the important thing, and if you do the Merkle tree version, you can say, look, this is one member in the Merkle tree, whatever. But the important thing about this one is that accumulator value, which is a constant size value, has in it all the information you need without having to use Merkle tree construction to check whether somebody holds ownership of an item in that accumulator, right? So it's a bit non-intuitive, but it's or maybe a bit hard to understand, but it's pretty revolutionary in terms of its capabilities. And the simplest version of accumulator is I give you this accumulator value, and so there's an accumulator value that's public, like on the blockchain, for example. It's stored inside a smart contract, and I can say, if I want to prove, say that the accumulator value represents a set of token balances, right, or a set of balances in a cryptocurrency, and I give you, and you're somebody else who is interested in transacting on the blockchain, if I really do hold a set of tokens in this accumulator, or in this blockchain balance, I can take my private key, and that is in the accumulator set, and use it to generate a witness, so the witness that's in there, to prove to you that I have a value in that set, and I can also transfer that value to you. And when I transfer that value, I create a new accumulator set value and update that in a smart contract. So the smart contract gets the newest state, but it doesn't know what's happened, right? All the smart contract knows is somebody did something that was valid, and here's the new cumulative set of balances. And without the witness values, so like the witness is a term in cryptography for basically auxiliary data needed to prove a statement. If you have the witness value, can you prove to somebody else what your balance is, right? So it's similar to actually to how Zcash works, but with a bit different properties. So these can be used for private transactions because they allow a party to update the accumulator state, accumulator X, without revealing what they did, but being able to selectively prove an insertion into the set using the witness if they choose to. So yeah, it gives us similar properties to ZK snarks like used in Zcash, but because the operation set is more restricted, you can only really do existence checks and set operations instead of arbitrary circuits. They're much more efficient. So if comparing this scheme to Zcash, for example, Zcash transactions right now take 40 plus seconds to generate, and gigabytes of RAM, where this is in the milliseconds. I think even with the much bigger, with the much better performing Zcash curve that they're planning to hard fork to, that's still a few seconds. Where this is pretty constant time, and it allows you to, it's a constant size and sublinear growth of the set. Which is really good for scalability. So here's a little representation of how this would work. Don't worry about the variables. It's just kind of like an analogy. But so say that this would be like the set of users that hold tokens in the hold balances in the token represented by the accumulator. And so a user with balance in accumulator X can provide a witness X to prove ownership of a set of tokens. To transfer the tokens, user X can perform this operation, which takes his secret and public key inside the accumulator, the state of the accumulator, some auxiliary data, and the structure T, which is kind of like a UTXO, and they get, as a result of running this computation, they get two values, the new accumulator set and the witness value. So it's actually, if you look at this, if you have ever looked at the Zcash white paper, you kind of have a similar transition functions for approving crypto nodes. And the user, if I'm transferring something to, if I'm transferring these tokens to somebody else, and I want to prove to them that I either want to prove to them or want them to be able to prove to others that they now have those tokens. I can just do it by providing the witness X to the counterparty. Double spends and things like that can either be rendered with deletion operations, which are also supported in the accumulator set, or with some other zero-knowledge properties. So, however, the fun part is that the accumulator value, the rolling accumulator value, can stay public, and anyone can run a function that takes the previous accumulator state and the newest accumulator state to check that the newest accumulator state, accumulator X prime, is a child of accumulator X and has a valid transition, right? So meaning I didn't create money out of nowhere, I didn't destroy money, I didn't do something that was weird and like mess with everybody's balances. And this scheme, this is not an exchange by itself. This is really just a cryptocurrency. This is kind of how to create a tokenized cryptocurrency where in a smart contract where all the transfers are private, but you can still prove to any third party that things are actually transacted. If you wanted to turn this into an exchange, all you really have to do is so actually here's some background first. The accumulator, the zero-knowledge accumulator, can be implemented over bilinear pairings. And bilinear pairings is something that's supported in Ethereum on the smart contract level. It's just it's kind of like a cryptography trick. And what can also be implemented with bilinear pairings is zk snarks themselves, right? So zk snarks, like as said before, instead of being restricted to a domain, they are arbitrary. And the nice thing about zk snarks is that while the computation for a proof can be quite high, once you have the proof generated, checking the proof is constant time, or about constant time, right? It's about 01. So if I take this as it is now, and that token is represented on the level of the blockchain, you can see that in the cylinders, you never submit the witnesses, right? You only really update like a rolling state of accumulator X. All these witnesses are kind of off-chain, and only the people who have the witnesses really can really know where the balances are, right? And if you make it so that you enforce in the smart contract that a zk snark must validate before the accumulator can be updated, related to like the distribution of the witnesses, you can actually turn that into an exchange where the zk snark circuit makes it so that, for example, you can't get this value unless I also get this other value, right? So that's a trade, right? Your balance can't be updated by 10 if my balance is not also updated by 10, right? So that's like a swap. So you can do a zk snark or a snark circuit of the swaps that is enforced in the smart contract. The smart contract just makes sure that if something illegal happened, you just can't update it, but otherwise it doesn't care and nobody else knows anything, but everybody knows that everything happened fairly. So I think I'm running out of time, so if you have any questions.
If you have any questions, you can find Matt probably in the back somewhere.
Okay. We're out of time completely?
We don't, believe it or not, we don't have time for questions.
Damn it. Right.
But we have one last speaker, David from OmiseGO, is going to talk about plasma.
Okay. Well, yeah.
Thank you, Matt.
Cheers. You can find me around later.
Awesome. Thank you so much. That was super interesting. Very, very important piece. Cool. So my name's David, and I'm a plasma researcher for OmiseGO, and scaling's the name of the game right now, and we're working on one of a few scaling solutions from the bottom up, and today I'm going to share that with all of you. Cool. So first, for those of you who don't know, what is plasma, the thing that I'm talking about? Then I'm going to give a big picture, general overview of kind of like the big game plan of what we're going to do with Plasma. And then I'm going to go over the MVP, which was formally specified by Vitalik quite recently. And I'm going to explain some choice pieces out of that I think are super cool. Hopefully you will too. So, what is it? It's all about scaling through compaction. So basically what we're doing here is we have a bunch of UTXOs. Pay attention to Alice's UTXO. We're going to use that later. And then we have the UTXO set, which is, in this case, the combination of all UTXOs makes the state. And then we crunch it down into a restorable state. And this basically allows us to get a lot more bang for our buck when we're tracking the state of a chain. But we don't want to lose that state. So how do we get the small state and turn it into the big state again? Well, we do it through cryptography. And so this is very reductionist, but basically what we're doing is someone creates a proof that they had, say, a given UTXO at a given block. Then they submit it to the small restorable state that's kept track of on, like in the V1, it's going to be on Ethereum. And then basically, once they prove that, hey, this UTXO is mine and I had this amount, then from the restorable state, we basically pop out the UTXO on the parent chain, and that's how they get their money back. And so how do these proofs get made? Well, one of the easiest proofs is using Merkle trees, and that's a proof of inclusion. And so what does that look like? So hashing, first of all, is pretty much a deterministic one-way function that takes pretty much any piece of information and compacts it down to a very small size in a deterministic way. And using hashing, we can create Merkle trees, which are super cool. They're used all over the blockchain world, and now I'm going to tell you about them a little. So down here we have these UTXOs, and then we hash these UTXOs to compact them a little bit, and then we just start hashing them together a little more and a little more until we get one hash that represents the entire UTXO set. And we submit that one hash to the parent chain where it's safely stored. And that hash is representative, in this case, of the restorable state. But we still haven't covered the proof. Well, this is it right here. So basically, this is the UTXO we're trying to prove actually was in a given UTXO set. And so what we do is we kind of take its pathway up to creating the root hash, and we take each hash that it combined with and submit that as the proof. So it's basically a list of hashes we need to combine with the hash of that UTXO we're trying to prove, and then we submit that to the parent chain, once again in V1, Ethereum, and boom, proof of a UTXO within a relatively small size. So, big picture. What's going on right now and what are our long-term plans? So V1 is pretty simple. We're going to support deposits on the parent chain. Then the deposits, in this case UTXO, will go to the child chain, and then people will be able to basically make payments with UTXOs back and forth between each other, and then they'll be able to securely retrieve their UTXOs on the parent chain. V2. Boom, got a little more complex. So now here we actually have the first semblance of an exchange. And basically people will be able to make trade transactions, and we're going to be tracking those. At least right now we're going to be using Merkles once again to track the order that the trades came in. Then we're going to accumulate an order book. This is all happening on child chains to avoid using up Ethereum mainnet bandwidth. And then we're going to deterministically choose which orders get filled, which ones get partially filled, and which ones don't make it at all. But what if something bad happens? Well, luckily, the entire time we're tracking what's going on using cryptography. So if something bad happens, basically people this is like super reductionist just because I don't have time, but people will be able to submit proofs of basically where something went wrong, and they'll be able to prove that it was in fact wrong. And by doing this, we can basically find out the bad actor and restore state to how it should be. Just in this example here, we're using basically a Merkle tree that's keeping track of the deterministic order matching. And so we can prove the spot where things went wrong using that with fraud proofs. Boom. And now 3 plasma chains on plasma chains on plasma chains. So this is really where the scaling comes in. So at first, we're just building one child chain, plasma chain, and it's going to be talking to Ethereum. But we're going to take it a step further. So we're going to have one plasma chain that is both a child and a parent of another plasma chain. And so just imagine a root system or a tree system just branching out. And that's where the near limitless possibilities come from. But they're in research, so it's not tomorrow. Cool. There's a little more. Okay, the MVP. So how do deposits work? So basically, someone deposits to the root chain, and they submit a UTXO, and this is what I'm pumped about this. So basically, we have the child chain going on over here, and like a blockchain, it has blocks. But as soon as someone deposits money, a block gets created on the level of the parent chain and is tracked in that smart contract as being a part of the child chain already. Why is this so cool? Well, even if as soon as someone deposits, the child chain never shows that their transaction came in, someone still can exit and withdraw because it's tracked right away on the parent chain level. What's super cool about this is it limits attack vectors. Now, instead of thinking about deposits and canceling deposits, we're only thinking about withdrawals and exits, because as soon as someone deposits to get their money out, they'll exit. Cool. Here's how transactions look. So in the V1, it's a max of 2 inputs and 2 outputs. Someone can do 2 inputs, 1 output, 1 input, 2 outputs. You get the idea. And so the inputs are basically referencing past transactions where basically valued was transfer, and they're basically specifying the position in the child chain that those transactions took place. And they also contain signatures from the owners of those inputs created in those transactions, because, well, basically you have to have the owner of the values go ahead before it's spendable. And then the output basically specifies the new owners and the amount that they're going to own. And lastly, we have a fee. This is just, this will be used to keep the network secure. In the MVP, it's a proof of authority chain, so one person will be collecting fees, but in production, it'll be a proof of stake system, and the fees will go to the validators that are securing a given child chain. Boom, but we're not done yet. So, to prevent a lot of bad things from happening, I'll just go through the story of how it could happen. So basically, Alice sends a transaction to Bob, but the proof of authority operator of the chain decides to withhold that transaction. Basically, now we're in a bad situation where no one can exit because Bob doesn't have access. He hasn't officially gotten the funds, but if Alice tries to exit, then the operator could basically create a valid challenge because Alice has signed off on the transaction. It just hasn't been broadcast and included yet. And so basically the confirmations, anyway. So the confirmations are basically the owners of input 1 and input 2 signing off that their transaction has been included in the parent chain. And that way, at one time, either Alice or Bob can exit, and the operator can never freeze people's funds, basically. But what if something goes wrong? Well, in V1, the Plasma MVP, exit. If anything goes wrong, whether the child chain goes offline or whether invalid transactions start getting included in the child chain, you have to exit, and you have to exit within a timely manner. And why does exiting work so well? Boom, priority queue. Super cool thing. So basically, these are UTXOs, and withdrawals get processed in order that these UTXOs are created. So valid UTXOs are being created, valid UTXOs are being created, and then boom, somehow an invalid UTXO gets included. The valid UTXOs that are created first are processed and successfully exit. So by the time we get to the invalid UTXO, there will be no funds remaining for it to exit with. Cool. That was a very short rundown. My name is David Knott, and yeah, it's awesome being here. Thank you for having me.
So my question would be is, why did you decide to take it up on yourself as OmiseGO to already develop Plasma instead of waiting for others to do so? Because I believe you're also using Tendermint already. So what was the reasoning behind that?
So scaling's the name of the game, and kind of hoping to solve that has been in OmiseGO's roadmap for quite some time. Eventually, not only do we want Plasma to scale, but we want to kind of add in cross-chain compatibility pieces. To be honest, I think like we could wait for other people and or other teams to solve it, but yeah, we're trying our best to kind of solve scaling first and help the ecosystem, because it needs to be done, and we don't want everyone to be waiting.
Yeah, I think I give it back to Peter. Yeah.
Yeah. Thank you, David.
Oh, thank you.
I have my. Do we have the final slide or?
Yeah. Oh.
Can we get the final slide? I don't know if there's anything on it, but.
That's not the. I'm sorry.
3 points. So thanks everyone for coming to this initial meetup, and thank you for all the teams that attended the workshop. We had Melonport, 0x, Kyber, AirSwap, Radar Relay, Gnosis, Augur, Omise, Crypto Derivatives. We had Matt that was presenting today, Alexia Kunov, and Polychain and Herdius. So thank you very much for coming to the workshop. Hopefully it helped those projects to kind of figure out how we all fit in the space, and we'll let them to collaborate better on standards, and we'll be trying to help them as well. Yeah, and thanks for the projects that decided to present today to the community. And now feel free to talk to each other. I hope it wasn't too long, so there is still some time.